Hi everybody, this is a video explanation of problem number 1 from our notes where we were doing related rates continued. So let's go ahead and do this. And if you recall, the first thing I'd like you to do is to take a look at that question at the end to see what is our unknown and what we are trying to find. So if you look here, we are asking for how fast is the distance between the cars changing. So the first thing that we would do is to draw a picture. So that's going to help us see what is happening with this problem. So we have a triangle, and let's talk again. Take a look here. North is headed up. West is headed to the left. So this direction is our north, and this direction is our west. So what we are asking for is how fast is the distance between changing. So between them is this hypotenuse right here, right along there. So we need to take a look at what our givens are. And if you look where it says north at 50, we have the change in the north direction. We're going to make this be the y and make this be the x. We're going to have the change in the north direction as dy dt, because it's with respect to time, of that 50 miles per hour. And when we're talking about the change in the west, we have that 40 miles per hour. So we're going to have dx dt is equal to 40 miles per hour. What else do we know? We know, let's take a look right here. We know it is 2 hours later. So we would have our time is equal to 2. So the thing we need to figure out is what are those distances y and x. So remember, distance equals rate times time. So on the y, we would multiply the 50 times 2, and that distance would be 100 miles. And on the x, we would multiply the 40 times 2, and that would be the 80 miles. So the other thing we need is we need the length of that hypotenuse, because it is the change in that we are trying to find. So to find the length of z in a right triangle, we are using the Pythagorean theorem. So we would have x squared plus y squared equals z squared. Plug in those x and y values of that 80 squared plus the 100 squared equal to z squared. And I trust we can do this. Our length z ends up being around 128. So we're going to put the little 128 there. So we can now put together our steps to go ahead and do this. So the first thing we have is we want to find, in this case, that change between the cars, which is the change on the hypotenuse. The next thing we're going to identify are the givens. And we have quite a few. So we know our x value is 80, our y is 100, our z is 128. We know our dx dt was the 40, and we know our dy dt was the 50. So the next thing we always talk about is what equation are we going to use? And in this case, our equation, remember, right triangle, we are going to be using the Pythagorean theorem. So x squared plus y squared equals z squared. The next thing we need to do is to find the derivative of that, and then we're going to substitute those values. So let's head up here. So number 4, we are doing the derivative, and of the x squared plus y squared equals z squared. So we're going to take the derivative of each of these, and it's going to be dx dt plus 2y dy dt is equal to our 2z dz dt. So at this point, we're going to substitute our values and figure out what dz dt is. So this step is substitute our givens. we have the x is 80 and the dx dt was our 40 plus 2 times the y, which was 100, and our dy dt is 50. This is all equal to 2, and our z was the 128. And then we have that unknown of dz dt that we're going to solve for. So this basically comes down to algebra, and I'm not going to show all these steps, but all we are doing is simplifying each of these, and then we're going to be dividing by the constant in front of the dz dt. So what we have is 16,400 divided by the constant in front, the 256, is equal to our rate of dz dt. And when we calculate that, we end up with 64 times 0.06. And that would be miles per hour. All right, that's example number 1. If you guys have any questions, let me know. See you next time.